Hello, and welcome to our webinar, Three Types of Railcar Unloading Systems for Efficiency and Economy, brought to you by Conair. My name is Jim Calairi. I'm the Editorial Director of Plastics Technology, and I will be your moderator. Our presenters today are Nicholas Paradiso and Justin Carter. Nicholas is the Director of Conair's Systems Group, leading technical sales, estimating, applications engineering, project management, and project engineering teams for both central material handling systems as well as heat transfer systems. Nick has a bachelor's degree in mechanical engineering from Northeastern University and is an MBA candidate attending Carnegie Mellon University's Tepper School of Business. Nick's 10 years of system experience comes from holding key leadership and technical roles within the plastics industry, establishing himself as a subject matter expert on integrated systems for plastics manufacturing facilities. Jason is conveying product manager. He is tasked with being Conair's definitive expert in the conveying product line and leading that flagship product line. Justin has worked at Conair since March 2016, primarily working as a project manager in both material handling and heat transfer systems. Justin has a bachelor's degree in secondary education mathematics. Please feel free to ask questions at any time during the presentation. Type in your questions at the bottom of the pane on the right-hand side of your screen. We'll direct as many questions as possible to Nick and Justin following their presentation. Gentlemen.
Okay, Jim, thank you. Again, I'm Nick Paradiso. I'm sitting here next to Justin Carter, and we're here to talk to you today about our railcar unloading systems and the various different iterations of this product line. Starting with Justin, we'll start with our vacuum railcar unloading systems.
Thank you. So we have a few different styles of vacuum unloading. The first one, we have our single pump reversing air system. There's a few advantages to it. This method is the most cost effective. We have shorter cycle times due to the pressure unloading. We're able to run without a high level switch on here. Filter cleaning after each cycle when the pump reverses. Some limitations of this type, we do want to use it with pelletized material only. We don't want to do regrind, any sort of flake or anything like that. It is limited to 400 feet max conveying distance, and we're capable of doing 12,000 pounds per hour. With this system, it's primarily comprised of four components. We have the conventional vacuum loading, but continuous pump operation. The control can accommodate up to 4 silos. It's available in 10 horsepower, 15 horsepower, and 25 horsepower models. The way this will operate is you'll go into vacuum mode first. It'll pull the material from the vessel up into the receiver. At a certain time, it will then reverse and allow the material to discharge into the vessel. At that point, the filter cleaning also takes place where the air that is being blown into the receiver will then clean the filter that's located in it. Our cycling loader, it's also an economical solution when you compare it to dual pump, dual motor railcar unloading systems. It basically does a vacuum and pressure cycle with the same pump. It does cycle between the two, so it's non-continuous. It's a turnkey solution, which means we basically have it all packaged on one movable platform. It's like the VRU system, capable of handling up to 12,000 pounds per hour. It has the automatic filter cleaning every cycle, and as you can see in the graphic, the performance is variable depending on different distance parameters. With this system, the pump will pull vacuum and it loads our hopper. When that hopper is loading, it's going to continue until the level switch in the side of the unit is satisfied. Once that level switch is satisfied, there will be a valve that will change position, and the pressure pump is now going to start blowing the material into your silo. At the same time, it's also cleaning the filter.
Awesome. Thank you, Justin. Yeah, so the first two options or offerings that Conair has had for quite some time, they are very popular. They are, I would say, the economical solutions. And then now what we're going to talk about are the more system-based, I should say, customized for each application offerings that we have in both our single pump, single motor, and dual pump, dual motor systems. What the definition of a single pump, single motor, and dual pump, dual motor is based on just how many pumps are in the system. But how these work are we use vacuum to pull the material out of the rail car at various distances for various throughputs and whatever else the application is calling for. We have a cyclone airlock assembly. This is where we transfer the system from vacuum operation to pressure conveying. The airlock is located right around here. We show this in detail a little bit later in the presentation, but that airlock is just isolating the two different environments where the vacuum pulls it out, and then we're going to pressure convey up into the silo. Again, single pump, single motor. That's just one pump is operating both the vacuum and the pressure side of the system. Over on the right, the dual pump, dual motor, same concept, but now we're able to isolate the vacuum side from the pressure side, which gives us the flexibility to run different line sizes or different distances for whatever the application is calling for. Same concept, vacuum pump is going to pull the material out of the rail car. We're going to use this stack up assembly, the vacuum to pressure assembly, to transfer it now to pressure, and we're going to blow the material up into the various silos in your system. Just before we move on, this is all technology that we acquired about end of 2020. We acquired the company of Phoenix Systems Corporation, and we've now integrated this fully into the Conair offering, all within our engineering and our envelope of products here. It's been very exciting for us because it not only, of course, gave us more control, and we've also been able to create some efficiencies there and utilize this technology in other parts of our offering, such as in-plant pressure systems and in-plant continuous vacuum systems as well. Quick little overview, just with the same type of format like we were showing before. If you remember the vacuum rail car unloading, that was our option one, was limited to about 12,000 pounds an hour, and that was static to the silo itself. You had to have the receiver up on top, and you're isolated to only filling that one or up to 4 silos, depending on how many receivers were in the system. Option two was that same throughput level of 12,000 pounds an hour, but it was now on a mobile cart. You can take a fork truck and move that cycling loader around. Gave you a little bit more flexibility on some of the distances, but again, it was still limited to that 4-inch line, so to speak, 12,000 pounds an hour rating. Now, if we're looking at single pump, single motor, we increase that capability for this option. So up to 18,000 pounds an hour. We do show this inline angel hair trap, where we do everything we possibly can on the system design to watch our conveying speeds. There are some materials that you just can't get away from angel hair generation. Your lower linear density polyethylene is a great example of that. It is going to generate angel hair. So we have these traps involved just to be able to prevent it from and scrub it from the system before we blow the material up into your silos. This is available in both 4-inch and 5-inch iterations, and it just gives you different capabilities there. You'll see the throughputs down on the bottom. Now let's talk about the dual pump, dual motor. This, I would say, is really our flagship. We've very popular product line for us for quite some time, especially in the last couple of years when bulk handling and storage systems have been of high demand in our industry. Up to 30,000 pounds an hour. These things are workhorses. In fact, we've pushed the limit here with some engineering and some design constraints there. But point being, like I said before, we isolate the vacuum system from the pressure system, and that's what's important here. If you have a rail car application where you have 8 cars you got to pull from, and we can't bifurcate in the middle of those 8 cars to go 4 and 4. We have to go down the whole run of 8. We may want to design that vacuum side with 6-inch, for example. And if the system is sitting right next to your silos where you don't have to go a great distance and it makes the throughput work, we may do this with 4-inch on the pressure side. So we can mix and match really anything here. We've really seen it all to be able to split this up. And really the big difference here is the airlock, excuse me, I don't point it out, but the airlock that's right here, right before the material drops into the pressure side, that's what we're using to separate the vacuum from the pressure. Same here, all of our standard offerings come with this angel hair trap, whether you need it or you don't, it's gonna come with it. Not only for protection, but also it adds, it's our adapter, so to speak, from the cyclone to the top of the airlock. So we utilize that from a mechanical integration standpoint. We're going to talk about application, I should say alterations to this system here in a little bit, but we do offer this also for powders and not only just for pellets or flake. Let's dive into each of the different components now of a dual pump, dual motor system. I color coded them here and we'll walk through. Of course, here's our vacuum pump. So like I said, because we're splitting the vacuum system up from the pressure, now we can size the vacuum system that's going to meet some of your requirements. You may have a throughput requirement from the farthest car, or you may have a throughput requirement from the closest car, and then we can let that taper off to the farthest car based on the physics of the system, not being able to make the same rate at the farthest car versus the earliest one. Point being, this is a positive displacement pump, and we size it for your application from an ICFM standpoint. Now, before the air makes it into the vacuum pump, we have to filter it. So we have a manual filter, which is essentially a cartridge filter that needs to be checked on a certain iteration of time, depending on your application, or we can upgrade these systems to have an automatic filter. And what that automatic filter is essentially a large baghouse where it's going to have automatic filter cleaning on it. We're going to pulse compressed air down on those bags during the conveying cycle, keep them clean. And then you have just this little container down on the bottom that you have to maintain every now and then and clean out. Notice we show a little butterfly valve here. You can shut the system, I should say, shut the butterfly off, change the little canister out, and the system can stay in operation, just isolating the vacuum there to be able to clean it out, put it back in, open the butterfly valve to let the dust fall down into the bottom. Now here's that cyclone airlock assembly here. I know, of course, we show the angel hair trap again, just showing the different iterations of the size. So based on your vacuum sizing, the vacuum pump sizing that's required, that's also going to now dictate a line size. And then based on the line size, we have 3 different cyclone offerings, one at 4-inch, 5-inch, and 6-inch. Getting into the weeds a little bit on the details, but we do have these different offerings. It's all part of the package that we put together for the different applications that we sell against. We're showing the pressure pump, same concept as the vacuum side. It's a positive displacement pump, and we just filter the inlet air, and then we have a silencer, and then we blow that air out through an optional aftercooler, depending on the application, which we'll get to in a second. And then we pass that through the takeoff on the bottom of the airlock to blow the material up into the silo or silos. Here's the aftercooler. It is optional. There are some certain materials that we recommend, and sometimes we don't necessarily recommend. We'll put it in the proposal because it's required. This is all based on location of the system as well as the material that you're conveying. A system that's going to be installed up in Canada is going to be, for the same application, is going to most likely not require an aftercooler, depending on the material, where if we take that same system and install it down in Louisiana or somewhere where it's extremely hot in the summer months, we're going to want to use this aftercooler because this pressure pump is going to have a delta temperature increase anyways. But notice that the air is coming from the atmosphere, right? So it's coming from the outside before it hits that inlet filter. So depending on whatever temperature you start with, we have that delta T that we're going through the pump anyways. But the cooler the air going in, sometimes if we look at that, the outlet discharge air in our calculations, it may be low enough where you don't have to cool it down, depending on if we're down south where we're most likely going to be using an aftercooler anyways, just to cool that air off. Air to air standard. Sometimes we do water cooled offerings depending on where the system is going to be installed. I touched based on this little technical blurb here. I got 2 slides just talking about rough application. stuff. This one is the throughput D rate. So depending on what's going on, this one I think I'm showing 8 cars like the example I used before. But the throughput is going to derate based on your distance. So your closest car is going to see your greatest throughput. And as you start to go farther and farther down the line, if we can't bifurcate and maybe split it in the middle, whatever else, that farthest car is going to see a lot less of a throughput in the system. There's a bunch of physics as to why that is, but really at the end of the day, there's a larger, as you continue to get farther and farther away from your vacuum pump, you're seeing a greater pressure drop in the system that you have to overcome. And as you start conveying material down that line, if you have elbows or whatever else, you have to get to that cyclone inlet. That's what's causing this derate in the system performance. So taking that into consideration, we get this all the time where we have customers that just tell us, well, I need 20,000, 30,000, whatever it is. I need a certain throughput at the farthest car. I don't care how far it is away. Like, it doesn't matter where that car compartment is. I got to make sure I get 20,000 pounds an hour like I'm showing here. Well, we have to do certain things to the system now based on the physics. So we size the system for worst case scenario. So we're sizing it for, I don't know, what, 400 or 500, 600 feet here, 20,000 pounds an hour. But then every pickup point that's closer to the vacuum pump, or I should say to the cyclone inlet where the material is going to be going in, that's going to see, if you don't use a VFD, if you just use a standard motor starter on your pump, you're going to start to see excess speeds, which is going to generate that angel hair. It's also going to hurt system performance because sometimes these pumps can only handle so much. So we'd use a VFD to dial that thing back. So we can use a VFD based on the position in which you're picking up on the rail car, and then we can also monitor vacuum pressures as well to understand, at least if a car is empty, alarm our customers' staff, and then they can go and change it over or change the little arm on the bottom of the compartment to get the other side before changing to a brand new compartment, whatever else. Quick little note here on the single pump, single motor. It is not as popular as the dual pump, dual motor for us anyways, because you have your limitations. We see some pretty wild applications that we've been able to overcome with our application engineering with the dual pump, dual motor, where it's rare for us to get a more simplified application, at least coming in our doors the last couple of years specifically. So the vacuum distance and the pressure distance, they just have to be relatively the same. The throughput is limited, like I showed before. But because of this constraint, because the vacuum and pressure distance have to be relatively at the same distances, it really has to do with this system only having a single pump. So that CFM is fixed. You have incoming CFM on the vacuum side, and that just gets transferred right to that pressure side CFM. We don't have the luxury of splitting that into 2 different vacuum and pressure pumps on a dual pump, dual motor. So this is an offering. It's something that we sell here and there, but it's not something that really has been too popular with us. We end up going dual pump, dual motor just because of the flexibility. A couple application notes here. I know I talked prior already about this inline filter, but if you are in a case where there is angel hair generation, like the lower linear density polyethylene specifically, we do recommend going to an inline filter receiver like this, because even though we have, when we're transferring from vacuum to pressure, we have that angel hair trap there, that you do still get some streamers and angel hair that end up getting pulled back to the vacuum, right, just through the way that the cyclone is operating. So in that case, we do like to have this inline filter receiver just because it's more convenient. You don't have to maintain that filter as often because it's a much larger vessel. And then we have the bigger takeoff canister on the bottom compared to the cartridge offering in the manual. Now, this is where I was talking before, where our standard offering is designed with the Cyclone for pellets, or really for flake pellets or whatever else that's larger than powder. So when you start getting to the microgranules or powder, this is where we have, we take that Cyclone out, which I show here, take that Cyclone airlock Cyclone and angel hair trap off, and now we're going to show this filter receiver. And this is just a very large powder receiver that we typically would use in compounding applications or in-plant vacuum systems. It's the same concept here. There's a bunch of bags that hang on the inside that are sized for the air to cloth ratio to be proper to the application. We pull the powder into the system. It's actually the inlet's down a little lower. Pull the air and material inside, and then the air gets filtered through the bags. And then here's our airlock. Same concept, just vacuum pressure transition with an airlock, but instead of a Cyclone, we have to capture all of that material and not allow any blow by back to the vacuum pump. And lastly, I touched base on this already. Of course, the aftercoolers are optional, but in some cases, we're going to recommend them for certain applications. A couple other items to talk about. So what I was saying before with our acquisition of Phoenix Systems and integrating this intellectual property into Conair, we now have been able to really expand our offerings to in-plant systems, which has been really great for us and really great for our customers as we start to get into certain applications. So if you noticed, remember on the dual pump, dual motor, how we're separating vacuum from pressure, we have the pressure side. So now we have pressure pumps, we have airlocks, we have all that sizing and that knowledge. We're able to now implement this for takeoffs underneath surge bins to blow up into silos or blow to different areas into your plant. And it's all the same sizing, the same technology. This was an interesting one. We got got a couple of these recently, which have seemed to be more popular. I don't really necessarily know what's going on with material supply, but this was one of them where customers were able to get their PET in sea containers instead of having to deal with their existing supply chain. So we have container discharge systems as well. Same concept as a rail car unloading, but that container gets dumped into a collection hopper, and then we use a pressure pump, aftercooler, airlock takeoff, and then we blow that material up into the silo. Been getting more popular. It's something to look out for. A couple other items to talk about are proofing options to these types of systems. So this is what we brand as our truck fill proofing, because it goes on the truck fill lines of a silo. But we have a good amount of customers that have manual connections between their dual pump, dual motor, or railcar unloading system offerings, even some cycling loaders where they're taking that pressure connection, they're hooking up to any one of their silo truck fill lines that they use for dual purpose for truck fill and for railcar fill. And they utilize this same locking mechanism. So it's a electromechanical lock that comes up on top. We have barcode capabilities where you can scan a barcode and unlock the silo that's associated with that material, with that lot number, with that Julian date. And it's something that I just wanted to talk about today because it's something that couples well with our railcar unloading system offerings. Now, again, this is the whole concept here is proofing, right? So we don't want to fill the wrong silo. I don't know if anyone on the call today has ever had to deal with that, but it's extremely expensive and it's a royal pain to have to empty a silo that's contaminated material. You can't use it, and you now have to find a space for all that material or send it back. Get a truck in, suck it out, and send it back. It's not good. So proofing is very important. Now, integrated into our controls of our railcar unloading systems, we can also do this with automatic valving. So this is just an example of a single inlet 4 outlet valve, but we can just use extend and retract signals to send this material really anywhere. So how this would work is we have the pump pressure that's sending the material off of that airlock. We would send this into the blue right there on the left. And if we want to send it to silo 2, we would just extend the valve for the valve number 2. Same thing here. If we want silo 3, silo 4, just going through a little stack of different slide gates. This is a way that the control itself can send the material to different silos where you don't have to have a manual connection. And now from a proofing standpoint, we monitor the end positions on these valves. So if we know that we send a signal to a valve and it doesn't change because it either got stuck or there's no compressed air or whatever happened, we're not gonna allow that material to convey, or we're gonna alarm, or we're gonna shut down. But also, as another double backup, we have a couple of customers that require both the end position switches and we're monitoring pressure as well. So if we have to fill silo 1, we're checking that end position switch, we're good. But and for whatever reason, we're seeing pressure on the silo 3 line and not the silo 1 line where we're supposed to be seeing the pressure in the system that we have calculated, we would also alarm and we'd shut down. So just a couple offerings there to talk about from a proofing standpoint to ensure that your operators are filling the right silo with the right material from the railcar system. Thank you for your time. Thank you.
Gentlemen, thank you for your presentation. We do have some questions here. There are a couple of folks asked about the availability of slides after the presentation. This is a recorded webinar, and everyone who registered will receive a link to the recorded version, which will be on the Plastics Technology website, ptonline.com. This presentation will also be on Conair's YouTube channel, so you can find it there. Above and beyond that, I would suggest that you reach out to Conair directly. So I hope that answers those questions. Got a couple coming in here. Our plant has used Conair cycling loader for years. Am I correct in thinking that this type of system just takes longer, but is just as effective as the other systems?
Yeah, so the cycling loader is as effective as other systems. The reason it may take a little bit longer, one, we're limited to the 4-inch line size. So depending on what throughput you're trying to get, that line size will dictate what's available. And then because the pump is constantly cycling between vacuum loading and then pressure blowing, it will take a little bit more time than, say, a dual pump, dual motor system.
Thank you. Are any of the solutions discussed here weatherproof for outdoor use?
That's a great question, Jim. Thank you. Yes, every single one of these systems here are for outdoor rating. Typically, the cycling loader, that's going to be sitting outside, just natural, because in most cases, it's very rare to see a rail car port that's covered. We do see them, but it's rare. But yep, so all this is outdoor rated. Same with the VRU systems are outdoor rated. And of course, our dual pump, dual motor systems are all outdoor rated as well. NEMA 4, if I remember correctly, is what the controls are all rated to. Where they could be outside.
Thank you. What are the typical operating pressure ranges of this system from inlet to outlet, back to the silo, and at the best performance possible of the whole system?
Sure. Yeah, positive displacement pumps. Let me go into one of the little guys that keep spinning so you see them. Yeah, these dual load positive displacement pumps, they're capable of up to, I guess these are larger, so up to maybe 15 or so inches of mercury, but the sweet spot is anywhere from 10 to 12 inches of mercury, and that really is dependent on the application, so that's why I'm giving you a window there. But yeah, the vacuum pumps and these types of systems are sized to operate at that certain level. We don't like to size anything above, somewhere right in the middle there. Don't want to give away our secrets, but yeah, it's somewhere in that window. On the pressure side, the pumps are capable of a lot more. That's why pressure conveying systems are capable of more. They can go farther. You can have more bends because you got up to about the pumps are rated to about 13, but like if you size to about 7, 8, or 9 psi, that happens to be really the sweet spot where the performance is going to be optimized. If you do the conversion from psi to inches of mercury, there's a lot more potential there on the pressure side than you do get on the vacuum side.
Thank you. In your experience, is it possible to install a rail car unloading system around existing silos, or does it need to be part of a new construction plan?
Sure, I could take that one as well. Yep. So we do this all the time. We upgrade old systems, or we install into existing silo farms. All you need is a concrete pad. Really, we can get creative to fit this equipment wherever you need it to. We have a couple of customers that actually had the Cyclone airlock assemblies about 100 feet away from where the pumps were. We just plumbed to it. Got to take that into consideration into the design. Just really plant layout. Let us know what's going on. Let our sales team know what you want, and we'll design around it.
Thank you. If needed, could this system work properly in the inverse mode? For example, from silo back to the rail car?
It's an interesting one. We have done rail car filling systems. It didn't necessarily come from a silo, but if you think of a silo as a bulk vessel, we got to pull off of it with vacuum, transfer it to pressure, and blow the material up to the top of a compartment on a rail car. I'm going to go ahead and say yes to that one. What do you think?
Yeah, I think we'd be able to make that happen.
Okay. This question comes from a company that has your flex control system. The question is, does it tie in? And if so, can we use the proofing locks on this that I saw at a Conair trade show?
Sure. So the dual pump, dual motor systems any of the unloading technologies right now do not tie into our FLX conveying control. The proofing system, we have the option of doing both a standalone proofing control or tying it into our smart FLX control platform.
Okay. Do you have any experience using this technology for non-plastics applications, food? Question here is specific to unpopped popcorn.
Unpopped popcorn, yeah. So I would say within the Conair umbrella, we focus on the plastics industry. Now, our parent company, Piavon, the Piavon Group, they have a leg of their business called Penta, and Penta is a specific product offering and really firm that supports the food industry. So if you do have any information there, please send that in, and we can get that into the right hands.
Thank you. Could you talk about railcar unloading of powders or granular materials with this technology?
Sure. Yeah, let me go back to my little thing here. Yep. So really granules and powders. So the big difference in this, and there's a couple other variables that you have to take into consideration with the bulk density of the material that you're picking up and what you're picking up out of. So we're looking at our pickup velocity. We're looking at the distance of the material, or the distance that you have to send the material. We're also looking at the throughput requirement. So that's all going to tell us how much airflow you need. That's going to size the pumps for us. The big differentiator, though, from a pellet system or a non-powder system, because we do flake, we do repro and whatever else, but anything that's non-powder, we would use a cyclone like this because you don't need a filter in it. We use the physics of the material coming in on a tangent and flowing down the cyclone, and it's separating from the airflow because the airflow continues up the center of the cyclone back to the vacuum pump, and the material starts to slow down via friction and via the cyclonic effect. There goes down, air goes up, and you're good because it's something that can separate from that air fairly easily from a pellet standpoint. From a powder standpoint, we don't have that luxury, so we have to send this material into a specifically designed filter receiver, and that filter receiver has a bunch of filters in it, of course, but there's a certain air to cloth ratio that we designed to based on the material, based on, of course, the bulk density. Is the material sticky? There's a couple other items that we're looking at. We sometimes, well, in fact, most, if not all times, we ask for a sample. We have a whole test rig here that we send our material through. It spits out a bunch of characteristics that we deem are important for a pneumatic conveying system, and then we design to that. But I hope that helps answer the question. It's possible with powders. We just have to use different equipment.
Thank you. Gentlemen, what are lead times like these days?
Great question. So we had an industry crisis. And when I say we, all of our competitors, including Conair, where the positive displacement pump industry was very backed up. We don't need to go into the details. It was the supply chain just went out of hand. Now we're getting through that, and Conair specifically has gotten past a lot of this with pre-ordering based on forecasts and some agreements we have with our suppliers to get on board with lead times. The other aspect to lead times really then comes into production capacity and really trying to keep up with just the surge in orders that our industry saw. And it wasn't just us, just with the fact that storage was extremely important. When our customers, when manufacturers were trying to keep up with their needs, they were not able to find resin. So when they did find resin, they ordered a lot of it, and they got it in bulk form. So they needed railcar unloading, they needed truck fill, and whatever else means of getting that material up. And they had to also store that material. So the silos and bulk storage product offerings for us just absolutely exploded over the last 3 years, and same with these types of product lines. So for your application, whoever's asking the question, contact our sales group. We'll give you a number. I won't broadcast it here, but it's something that we're actively continuing to try to work on because it's still not to pre-COVID levels. Let's just say that, Jim.
Thank you. This question may have been asked in a different way, but I'm going to ask it anyway. is there a way to use the positive displacement pump to fill the silo?
Yeah, so all of the products that we outlined today use a type of positive displacement pump. We use them in different ways depending on exactly what we're doing to put the material into the silo, but they are all positive displacement pumps that we're using.
Okay. You talked about several systems. Is there a benefit of one versus the other for cold regions and climates?
Cold regions and climates. Yeah, I mean, it depending on what you need. So this type of a system's fairly popular, I would say, in the cold regions, mainly because this pump, even though we show it in our marketing illustration here outside of the silo, most of the time it's down in the skirt of the silo itself. Now let me go to the little picture here. There are some valving on this that require compressed air, and in cold regions, of course, compressed air outside in the elements is something that we want to stay away from. And so it's from an economical standpoint, we do VRU systems because when that pump is down inside of the skirt, that pump is running and the temperature buildup inside of the skirt is always going to keep everything warm. So you're not going to have any freezing of your compressed air lines or not. Now, as the next, obviously the cycling loader, that's also going to be something that's subject to the freezing, so to speak. So perhaps not so much because you can't fit this inside of the skirt. But I do want to talk about our dual pump, single pump and dual pump dual motor offerings. Everything as a standard utilizes compressed air solenoids, but we do a good amount of systems with electrical actuated because, of course, there's throughput limitations on our VRU system, like I showed before, up to 12,000 pounds an hour. That's a small system for us. So we're up in the 20 to 30,000 pounds an hour range all the time. So we do systems like this up in many regions where compressed air is not something we can use. So we just use an electrical actuator where we need a valve.
Thank you. Would you be kind enough to share some contact information should a attendee look to reach out?
Sure. What's the best way to do that? We can share it as a blast after this. I don't have it on any of our slides to be able to write it down, but
okay, you can take care of it offline.
Okay.
We did have a couple of questions come in since I asked that one. What are the big challenges in the design of this system as a whole?
Probably the biggest one that we get, I would say, Justin, is our line size requirement. So we get a good amount of requests where, hey, I want 25,000 pounds an hour, but I have an existing 4-inch line that's 800 feet long. Can we use it? And having to explain that's just the physics are not there. It does not work. It won't work. Even if we wanted it to work, if we had a pump that could handle the pressure drop, which we don't, the industry doesn't, the speeds would be too fast. So yeah, there's a couple of really, I would just say, existing stipulations that we have to design against that we can't control. Of course, those are going to be challenges. And then also, I would have to just bring up just working with location of equipment. So let me go back to that little thing I show right here. Yeah, this is a good one. So I've mentioned a couple times a bifurcated system. So that's where if you have 8 cars like this, what we'd like to do is actually bring the line to grab the first 4 and then elbow. And then the second 4 on the right would also elbow, and it's a welded bifurcated Y to be able to pull from any of the cars on the same system. It's more efficient to do it that way. The issue, though, that we run into is sometimes there may be another rail car line here. There may be some sort of an ordinance that tells us we can't do a pipe bridge, so we have to bring the material all the way down and go through a trench. There's always something that comes up, but really location of equipment and really it's all application specific anyways, but existing line sizes really would be the challenges.
Thank you. Attendees should take note that we have in the chat box, you'll see some contact information. That's info@conairgroup.com should you be inclined to reach out after this presentation for further questions or more information. I think we have gone through the questions. So I would like to thank Nick and Justin of Conair for their very informative talk. I'd like to also thank all attendees for their attention and interaction. Lots of good questions. As I noted before, this webinar was recorded, and shortly everyone who registered will be receiving an email pointing you to the recorded version, which will be posted on the Plastics Technology website, ptonline.com. As I indicated before as well, this webinar will be posted on the YouTube channel, Conair's YouTube channel, so you can check it out again there. And concerning the recorded version that's on the Plastics Technology website, when you get that email advising you that it is ready to view again, you can view it again, or you can share the link with any of your colleagues who could not join us today. So once again, I'd like to thank everyone for their participation in this webinar. Gentlemen, thank you very much. Goodbye. Have a good day.
Thank you, Jim.
Thank you.